Welcome to another video on digital electronics. In this video, we'll see what a full adder is. Last video we had done half adder. I'm continuing full adder in this video. So why we need full adder? Because half adder gives you provision to add only 2 bits. But when I add 2 bit, I have a third bit carry which might be generated in certain cases. Like if I add 1 plus 1, my sum is 0 and my carry is 1. So for the next addition, if I am adding 1 plus 0, I also need to add this 1 here, which is the third bit. So this is not the provision in the half adder, hence we create a full adder. So let's take three inputs A, B and C. My output are still going to be sum and carry. So let's take all the combinations. Since we have three inputs, I'll have 8 combinations 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1 0 0, 1 0 1, 1 1 0 and 1 1 1. Let's try to figure out what the sum is going to be for 3 bits. So how do we add sum? We'll add 2 bit and then to that new sum we will add the third bit, right? So 0 plus 0 is 0. That sum 0 plus this carry 0 will of course give you sum 0 and carry 0. So let's do this again. 0 0 1. This is what we are adding here. I'm solving this case. 0 plus 0, my sum is 0 and my carry is also 0. To that sum 0, I'm adding my third bit 1. So my sum is 1, my carry is 0. So sum is 1 here and carry is 0. 0 plus 1. Sum is 1, carry is 0. To that sum 1, we are adding 0, which means sum is 1 and carry is 0. 0 1 1. 0 1 1. Let's add these two bits. My sum is 1, my carry is 0. To this sum 1, we are adding 1 here. 1 plus 1, sum is 0 and the carry generated here will be 1, right? So my sum is 0 here and my carry is 1. 1 plus 0, sum 1, carry 0. That sum 1 plus this 0, sum is 1, carry is 0. 1 0 1. 1 0 1. 1 plus 0. Sum is 1, carry is 0. That sum 1 plus this 1 will give you sum 0 and carry 1. So sum here is 0 and carry is 1 1 0. 1 plus 1, sum is 0, carry is 1. This sum 0 plus a 0 will give you sum 0, carry 1. The sum is 0 here and carry is 1. Last one, 1 1 1. Let's add first two bits, sum and carry. 1 plus 1, sum is 0, carry is 1. That sum 0 plus this 1 will give you sum 1 and carry 1. So last one is sum 1 and carry. Once we have the truth table, let us write the equations for sum and carry. So equation in an SOP form will search for ones and write those min terms, right? So I have A bar, B bar, C. So this is A bar, B bar, C plus A bar, B, C bar, A bar, B, C bar plus I have A, B bar, C bar, A, B bar, C bar plus last one is A, B, C, right? So let's try to solve this. I can take A bar common from first two terms. So I'm left with B bar C plus B C bar and I will take A common here. It is B bar C bar plus B C, right? So now I can write this as A bar. B bar C and B C bar is nothing but B XOR C plus A. B bar C bar plus BC is nothing but B XNOR C, right? So I can write this as A bar B XOR C plus A. B XNOR C is nothing but B XOR C the whole bar. It's the complement of XOR, right? So now I have made this equation in the form of A bar B. We will consider this as this whole as a term and this whole as a term. So see here, this looks like A bar. Let's take this term as X. So this is A bar x plus A x bar, which is nothing but A XOR X, right? And what is X? What is X? X is B XOR C. So this equation becomes A XOR B XOR C. That's your solved equation for sum. Let's go to carry now. Let's see the number of ones. So I have a 1 here, which is A bar BC. So you have A bar BC plus I have A B bar C, A B bar C plus I have A B C bar, A B C bar plus last one is A B C, A B C. Now this one is a bit tricky to solve, but you should know your theorems well to solve this one. What I can do is, since I have one ABC, A plus A is nothing but still A, right? So how much ever A's I add, it's still going to be A. So since I have ABC, I will add two more times ABC plus ABC. Why I am doing this? So that I can reduce this. I will also show you this using a K-map, which is much more simpler, but given a theorem, you should also know to solve this. So from these two terms, let's take BC common. So I am left with A bar plus A. I will change the color so there is no confusion. From these two terms in the blue, I will take AC common. So I am left with B bar plus B. And from these two terms, I will take AB common. And I am left with C bar plus C. Please note that I am making no change in the equation. Adding two more ABC will not change the meaning of the equation, right? Because A plus A plus A is nothing but A. So eventually this equation reduces to BC plus AC plus AB. This is a bit tricky to solve. Same thing would be solved using a K-map and you will get an exact same equation. Let's see how. Since this is 8 combinations, I will have an 8 variable 8 K map with 3 variables. This is my A, this is my BC, this is 0 1 0 0 0 1 1 1 and 1 0. Let's see where all we have ones in the carry. So I have at the third position 5 6 and 7. So this is 0 1 2 3 4 5 6 7, right? Any chance of making 8 ones? No. 4 ones? No. 2 ones? Yes. So I can make these two combinations, these two combinations, and these two combinations. So let's write down the equation for each one of them. For this combination, I have A common, so it's going to be A. From these two columns, I have C common, so which is AC plus. For the next combination, let's take this vertical one. So I have BC, since A is changing, we will avoid, and I have BC. So this is BC plus for this combination. For this combination, we have A common. So I will write it as A, and in these two columns, we have B common. So this is AB. Check this equation, exactly same. We have AB, BC, and AC, right? So there are two methods to solve this equation. And how do we implement this circuit? Sum is A XOR B XOR C, and your carry is this. So let's try to implement or realize this circuit. The best way is to make wires first and then make the connections. So let's say this is my A, this is my B, and this is my C. So I have A, B, C, 3 input to an XOR gate. This makes my sum, and my carry has AC into an AND gate. Then I have BC into an AND gate, and I have AB into an AND gate, and all three products are then added in an OR gate. So this is your carry and this is your sum. This is how you realize a full adder circuit. I will stop the video here. In the next lecture, we will do the subtractors. Thank you for watching.